The Sahara Desert has expanded by 10% in the last century. A recent study by the University of Maryland reveals, and you have the map showing just how much it was and how much it's gone to. It seems that the earth is drying up. The Sahara Desert has expanded by about 10% since 1920. This is according to the new study of University of Maryland scientists. Research is the first to assess century-scale changes to the boundaries of the world's largest deserts, the largest being Sahara, suggesting that other deserts could be expanding as well. The study was published in the journal Climate. Deserts are typically defined by low average annual rainfall, usually 100 millimeters, that's less than 4 inches per year. The researchers analyzed rainfall data recorded through Africa from 1920 to 2013, and they found that the Sahara, occupying much of the northern part of the African continent, expanded by 10% during this period when looking at annual trends. When the authors took out seasonal trends over the same period, the most notable expansion of the Sahara occurred in the summer, resulting in nearly 16% increase in the desert's average seasonal area over the 93-year span covered by the study. Quote, "Our results are specific to the Sahara, but they likely have implications for the world's other deserts." This is what Sumant Jinam, professor of atmospheric and ocean studies at University of Maryland, said. He's a senior author of the study. Nigam also has a joint appointment with UMD's Earth System Science Interdisciplinary Center, ESSIC. The results of the findings suggest that human-caused climate change, as well as natural climate cycles such as Atlantic Multi-Decadal Oscillation, AMO, cause the desert's expansion. The geographical pattern of expansion varied from season to season, the most notable differences occurring along the Sahara's northern and southern boundaries. Deserts generally form in the subtropics because of the Hadley circulation, through which air rises at the equator and descends in the subtropics. Climate change is likely to widen the Hadley circulation, causing northward advance of the subtropical deserts. The southward creep of Sahara suggests that additional mechanisms are at work as well, including climate cycles such as the AMO. The Sahara is the world's largest warm weather desert, roughly equal in size to the contiguous United States. The Arctic Basin and the Antarctic continent, which are each about twice as large as Sahara, also qualify as deserts due to their low rates of precipitation. And like all deserts, the boundaries of the Sahara fluctuate with the seasons, expanding in the dry weather, contracting during the wetter summers. The southern border of the Sahara adjoins the Sahel, the semi-arid transition zone that lies between the Sahara and the fertile savannas further south. The Sahara expands as the Sahel retreats, disrupting the region's fragile grassland ecosystems and human societies. Lake Chad, which sits at the center of the climatologically conflicting transition zone, serves as a bellwether for changing conditions in the Sahel. The Chad Basin falls in the region where the Sahara has crept southward, and the lake is drying out. Nigam explains its very visible footprint of reduced rainfall not just locally, but across the whole region. It's an integrator of declining water arrivals in the expansive Chad Basin. Declining water. Less water. The earth is drying up, of course, that way. A number of well-known climate cycles can affect rainfalls in the Sahara and the Sahel. The AMO, in which temperatures over a large swath of North Atlantic Ocean fluctuate between warm and cold phases on a 50 to 70-year cycle, is one example. Warm phases of the AMO are linked to increasing rainfall in the Sahel, while the opposite is true for the cold phases. For example, the notable drying of the Sahel from the 1950s to the 1980s has been attributed to one such cold phase. The Pacific Decalid oscillation, decadal oscillation, ODP, PDO, mark the temperature fluctuations in the Northern Pacific Ocean on the scale of 40 to 60 years, and that also plays a role. And singling out the effects of human-caused climate change, researchers use statistical models to remove the effects of the AMO-PDO on rainfall variability during the periods 1920 to 2013. And they concluded that these natural climate cycles accounted for about 2/3 of the total observed expansion of the Sahara. The remaining 1/3 can be attributed to climate change. But the authors say that longer climate records that extend across several climate cycles are needed to reach more definitive conclusions. Many previous studies documented trends in rainfall in the Sahara and the Sahel, but our paper is unique in that we use trends to infer changes in the desert expanse on the 10th century timescale, said Natalie Thomas, graduate student in atmospheric and ocean sciences in UMD, the lead author of the research paper. The study's results have far-reaching implications for the future of the Sahara, as well as other subtropical deserts around the world. As the world's population continues to grow, a reduction in arable land and adequate rainfall to support crops could have devastating consequences. The trends in Africa of hot summers getting hotter and rainy seasons drying out are linked with factors that include increasing greenhouse gases and aerosols in the atmosphere, said Ming Kai, the program director in National Science Foundation Division of Atmospheric and Geospace Sciences that funded the research. He said these trends have also a devastating effect on the lives of African people who depend on agricultural-based economies. Thomas and Nagum are focused on learning more about the drivers behind desert expansion of the Sahara and beyond. With the study, he says our priority was to document the long-term trends in rainfall and temperature in the Sahara. Our next step will be to look at what is driving these trends for the Sahara and elsewhere. Thomas said, we have already started looking at seasonal temperature trends over North America, for example, and here winters are getting warmer, but summers are about the same. In Africa, it's the opposite. Winters are holding steady, but summers are getting warmer, so the stresses in Africa are already more severe. This is by University of Maryland, and it's on Geology In. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.